Ever wondered why you age slower on a plane? Sounds like a science fiction narrative, doesn't it? Now let me pose another question. Have you ever pondered the intricate relationship between time and aging? The correlation might seem abstract, perhaps even a little perplexing, but it's a scientific reality we're going to unravel today. It's a journey that takes us beyond the realm of the everyday into the captivating universe of relativity and time dilation. Yes, you heard that right. It's time dilation that's the key player in this intriguing phenomenon. It's the peculiar way time behaves when you're cruising at high altitudes, the peculiar way that makes you age, albeit insignificantly slower on a plane than on the ground. So fasten your seatbelts, sit back, and get ready for an intellectual voyage that transcends the boundaries of time and space. Prepare to dive into the fascinating world of time dilation. First, we need to understand what time dilation is. This might sound like a concept plucked straight from a science fiction novel, but it's actually a fundamental part of our understanding of the universe, as proposed by Albert Einstein in his theory of relativity. So, what is time dilation? In the simplest terms, it's the idea that time doesn't tick at the same rate everywhere in the universe. It's not a constant, unchanging force as we might intuitively think. Instead, time can stretch and compress. It can dilate and contract. Now let's bring in Einstein, who had quite a bit to say about this. According to his theory of relativity, time and space aren't separate entities, but are interwoven into a single continuum known as space-time. And here's where things get a bit tricky. Einstein proposed that the speed of light is the only thing in the universe that remains constant for all observers, no matter their speed or direction. So what does this have to do with time dilation? Well, imagine you're moving at a speed close to that of light. To keep the speed of light constant, time must behave in a rather peculiar way. As you speed up, time slows down. It's a bit like the universe's own speed limit enforcement. Push too hard on the accelerator and the universe responds by slowing down your clock. Now, this isn't something we notice in our everyday lives. The speeds we travel at are far too slow to have a perceptible effect on time. But in extreme situations like near the speed of light or in the immense gravity of a black hole, time dilation becomes significant. So to sum up, time dilation is the stretching of time that occurs when you're moving at high speeds or existing in high gravity. It's a fundamental part of Einstein's theory of relativity, which tells us that time and space are not as constant as we might think. In essence, time dilation suggests that time slows down as you move faster. It's a mind-bending concept that has profound implications for our understanding of the universe and our place within it. But how does this relate to aging? How does time dilation affect our biological clocks? Well, let's delve into the concept that bridges the gap between the theory of relativity and the progression of time as we know it. Time dilation, in essence, suggests that as you move faster, time around you moves slower. Now apply this notion to the human body. If we could travel near the speed of light, the idea is that our bodies would age slower compared to a stationary person on Earth. The reason? Our biological clocks would be ticking slower relative to those on Earth. Let's illustrate this with a thought experiment known as the twin paradox. Picture a set of twins. One remains on Earth while the other embarks on a space journey, traveling at speeds close to that of light. As per Einstein's theory, the traveling twin experiences time dilation and upon return finds that they have aged slower than their earthbound sibling. In the eyes of the traveling twin, their journey may have felt like a few years, but for the twin on Earth, decades could have passed. The traveling twin has essentially taken a leap into the future, all while staying biologically younger. This is because the aging process, much like any biological process, is tied to the passage of time. Our cells divide, our bodies grow and mature, all in sync with the ticking of our biological clocks. If those clocks are slowed down by high-speed travel, then so too is the aging process. It's a fascinating concept that intertwines the realms of physics and biology, space and time, aging and youth. So theoretically, if you spent enough time traveling near the speed of light, you would age slower than someone who remained on Earth. But before you start planning your next cosmic vacation, remember that this is all purely theoretical. The practicality of such a journey, not to mention the effects on the human body, are topics for another discussion. But for now, let's just marvel at the wonders of time dilation and its potential implications on aging. Now let's bring this concept down to Earth, or rather up in the sky. Picture this. You're on board a fast-moving airplane soaring through the clouds. Did you know that as you cruise at high speed and altitude, you're actually experiencing a phenomenon called time dilation? Yes, it's not just a concept confined to the realm of theory or science fiction, but something that happens in real life. Let's delve into the details. Time dilation, according to Einstein's theory of relativity, is the difference in elapsed time measured by two observers. This difference is due to a velocity difference relative to each other, or to a difference in gravitational potential between their locations. Now, airplanes move quite fast, and they're also at a higher altitude where gravity is slightly weaker. These two factors contribute to time dilation. But what does this mean for you, the airplane passenger? Well, as your plane speeds through the sky, time on board is moving fractionally slower than time on the ground. This means that you, as a passenger, are aging slower than the people down on Earth. Fascinating, isn't it? However, before you get too excited about the prospect of eternal youth through frequent flying, it's important to note that this effect is incredibly tiny. So tiny, in fact, that it's virtually impossible to notice with the naked eye. To give you some perspective, 100 years of constant flight might make you about 1 second younger than someone who stayed on the ground. So while the effect is real, it's not exactly a fountain of youth. But it does provide a mind-bending realization. Every time we fly, we're experiencing a tiny bit of time travel. We're aging slower than our counterparts on the ground. We're slipping ever so slightly into the future. So, in a way, you're traveling into the future every time you take a flight. Let's recap what we've learned today. Time dilation, a fascinating concept birthed from Einstein's theory of relativity, explains why we age slower on a plane. When moving at high speeds or near massive objects, time tends to slow down. This is not mere conjecture, but a scientifically proven phenomenon. Take the twin paradox, for instance. If one twin embarks on a space journey at nearly the speed of light and returns, they'll find their Earth-bound sibling has aged more. This is time dilation in action. Now you may wonder, does this happen in real life? Indeed it does. GPS satellites experience time dilation due to their high speeds and distance from Earth's gravitational field. To maintain accuracy, they must adjust their clocks to match Earth's slower time. Next time you're on a plane, remember, you're not just traveling in space, but also in time. Now that you understand the science behind time dilation, what other questions does it spark? It's a concept that's as intriguing as it is complex, isn't it? It makes us think about time in an entirely new way. Instead of a constant, unchanging entity, time becomes fluid, bending and stretching in response to speed and gravity. Consider this, if we can age slower on a plane, what other peculiarities might we encounter in our vast universe? Could we, for example, age slower on different planets? What about black holes, those enigmatic cosmic objects with gravitational pulls so strong that not even light can escape? Could time come to a standstill at the edge of a black hole? Or think about space travel. We've all heard of the twin paradox, where one twin travels at near light speed while the other stays on Earth. According to time dilation, the traveling twin would age slower and return to find their Earth-bound sibling significantly older. Could this be a real possibility for future astronauts? Could time dilation be the key to long-distance space travel, allowing us to reach distant galaxies within a human lifetime? These are just a few of the mind-bending questions that arise when we delve into the science of time dilation. It's a topic that's ripe for exploration and discussion. So, we invite you to join the conversation. Share your thoughts, your questions, your theories. Let's dive into this fascinating subject together and see what new insights we can uncover. And as you ponder these questions, don't forget the beauty and mystery that surrounds us. Our universe is a magnificent tapestry, woven from the threads of time and space. Each thread is a story, a mystery, a question waiting to be answered. Remember, the universe is full of fascinating mysteries waiting to be discovered. Keep exploring, keep asking questions, and keep soaring through time.